Hi guys, so today we'll be talking about probability and binomial distributions and distinguishable permutations. So what is a probability distribution? It is a function that gives the probability of each possible value of a random variable. And a random variable is basically a way to map outcomes of random processes to numbers. So examples of random processes could be flipping coins, rolling dice, etc. And an example here is, so what we do in random variables is we assign numbers to these random processes, to their outcomes. So if we were flipping coins, we have heads and tails as our two possible outcomes. And we could assign heads with the number 1 and tails with the number 0. And we could do it the other way too. But there's a requirement of a probability distribution. The sum of all the possible outcomes in a probability distribution must equal 1. So in a coin, the probability that you get a head and a tail is equal. They're both 0.5, and 0.5 plus 0.5 is equal to 1. Now if you got something where the probabilities added up that was greater than 1 or less than 1, then it is not a probability distribution. Here's an example of a probability distribution. It kind of looks like a histogram. And here on the x-axis, we have like the different possible outcomes. So maybe we're talking about numbers of cards, 2, 3, 4, 5, and then we assign them their probabilities here, and we can match them on the graph. And a binomial distribution has certain requirements. So the requirements are here in bulleted, and they are n, which is the number of trials, should be known and must be random experiment. So what this means is that you can't say that the number of trials is infinite, so it has to be finite and it has to be known, the exact number, and it must be a random experiment. So for example, a random experiment could be flipping a coin. Each trial should be independent, and we could further use the flipping coin example. Just because we get heads when we flip a coin once doesn't mean we'll get tails the second time. Each trial is independent, and each trial can only have two possible outcomes, again using the coin experiment. Flipping a coin, you can only have two possible outcomes, and that is heads and tails. Or you could think of it as success and failure. And the probability of outcomes remains the same in each trial. So again, using the coin, the probability of getting a head is 0.5, and the probability of getting a tail is also 0.5. Now if you were talking about, for example, if you were doing multiple choice tests and you have 4 outcomes, or like A, B, C, D, so the probability of getting the answer right is always 1/4. You're not going to get a probability of getting an answer right of 1/2 or 2/4 unless it is a true or false question. And a binomial distribution demonstrates outcomes of a binomial experiment. So what exactly is the difference between a binomial and a normal distribution? So if you recall, the binomial distribution, one of its requirements is that the number of trials has to be finite and it should be known, as stated here. So it is a discrete distribution, and what a discrete means is that it is counted and it is a success or a failure. So meaning that, for example, if we're counting the number of times that a coin lands on heads, we are counting that. We are not measuring that. And we're counting the number of times that the dice lands on 1. However, a normal distribution is continuous, and we use some sort of tool to measure the data. So for example, we can use a ruler or a timer. So I think one way to remember discrete and continuous is that when you're using a measuring tool, for example, and you get a measurement of 8 inches, this is continuous because you're using a measuring tool, first of all. But also, if you think about it, you have 8.000000000, and you could have 1.00017, and it could be just a little bit over 8. However, if you're talking about discrete, and you're counting 8 dogs, for example, you can't say that I have 8.009 dogs. That's impossible to have a fraction of a dog. So there's something called a probability binomial distribution, and that is basically a distribution that has the characteristics of a probability distribution and a binomial distribution. So it has all the requirements. It follows all the requirements. So finding the probability of an outcome in a random experiment, we have a table here of flipping. So we had a flipping coin simulator, and we flipped the coin 20 times. So we had homework, which we had to fill out a survey of how many out of 20 times we flipped the coin, how many times did the coin land on tails. And this is basically the table of all the results from a total of 145 students. So again, as a reminder, the probability that an event occurs is the number of favorable outcomes over the number of possible outcomes. So in this case, the number of possible outcomes is 145 because we have 145 people and each person has a different outcome, or like each person has an outcome that is matched in these 0 to 20 the number of tails. So for example, the probability that we will have 9 of our coins land on tails, given that the total number of people who participated is 145. So we have to look at the table here. It says 9. The number that landed on tails is 9. And we look down and we see that the count frequency is 20, which means that there are 20 people who had 9 of their 20 coins land on tails. Now, in order to find the probability that we are going to have 9 of our coins land on tails, we're not going to divide 9 by 20 as most people would probably do instantly. Instead, we are going to divide the count frequency, which is the number of people who got this, out of the total number of possible outcomes. So the number of people who've got 9 over the total number of people, and that is 20 divided by 145, which is 0.1379. And last but not least, distinguishable permutations. So these are basically combinations in which the order matters for everything. Now that may sound weird because permutations and combinations, the only thing that separates them is basically permutations order matters, but this is a type of permutation where we have repeats. And here's an example below. So for example, we have the word Miami. Now, how many ways can we arrange the letters in this word? Now, order matters here, but we realize that we have some repeating letters such as M and I. So how are we going to find out the total number of ways we can arrange this? So what we're going to try to do here is to eliminate the repeating, like for example, M, and I'm going to use a different color, or italicize Miami and Miami. These are the same, basically the order, although the order is different because the italicized I is here versus here, we can't really tell if this weren't italicized. So this is what the combination does. This is why we are calling them basically combinations, because there are redundancies which we have to eliminate, although the order does matter. So what we're going to do is we're going to pretend that this doesn't have any repeating letters, and we're going to do the total number of letters in Miami, 1, 2, 3, 4, 5 factorial, divided by the... So now what we're going to do here is we're going to arrange the letter, the word by the letter to find the total number of possible ways we can arrange this without repetition. So first we start with M. Right now we have a total number of 5 letters. So 5, C, and we have 2 M's, so we do 2. and then we multiply this by, now we have, since we already have the two m's, we have 3 letters left total, I, A, I, and we can count the number of letters of I, which is 2, 3 2's 2, and now we only have one letter left, which is A, so we have 1, choose 1, and we multiply all of this together, and we divide 5 factorial by what we got here, and we get a total of 30 combinations. So a more simplified explanation of this is that Miami has 2 repeating letters, M and I, and they are both repeated 2 times, so you can divide 5 factorial, which is the total number of letters, by the number of times each letter is repeated, if they are repeated, to get the total number of combinations. And this is the formula for the distinguishable permutations / basically combinations, where n is the total amount in a set. So in this case, it was 5 letters, since there were total 5 letters, and n1 and n2 represent the I and the M, which are the repeating letters. That's all I have today, and thank you so much for watching.